Bienvenidos, Ushamdi, and welcome to this Hut8 Networking Techtorial. In this Techtorial, we're going to complete the second of a two-part series on the BGP Remove Private AS feature. And in this video, we're going to take a look at the Remove Private AS, and we're going to add the All Replace AS. If you remember from the first video, when we used only Remove Private AS, it simply removed the private AS and didn't replace it with anything. In other words, the AS path length was changed because we're removing the private AS, and so when you looked at the internet side, it had not been picked up, and so it appeared as if that NLRI was originated from the AS where we did the remove private AS. So now we're going to remove the private AS, and we're going to replace all occurrences of the AS with the AS from the router or from the autonomous system that is doing the remove private AS. And so let's take a look and dive in here. And let's first look at our diagram. So we have the diagram here from earlier where we were doing AS path prepending, and we had some iBGP configured in here, and we had eBGP peerings, but we had this private autonomous system number. But on router 4, which was in autonomous system 4, when we ran the command show IP BGP, it appeared as if all of the NLRI that had been originated here in AS 65488, the private AS, when it showed up over here, it looked like it had originated in autonomous system 23, because on router 2 and 3, that's where we did the remove private AS. So now we're going to go ahead, we're going to take a look at what happens when we do the remove private AS, and actually let's go ahead and let me stretch this out here, and let's add this in real quickly. We're going to say remove private AS, and let's get the caps lock on all, and we're going to go ahead and have replace AS, replace dash AS. And let me recenter this here. There we go. All right, so that is what we're going to be doing with these guys here. And let's drag this a little bit this way, and we don't want the autonomous system number coming with us. So we'll bring it back to the center there. All right, and what's going to happen is on router 4, instead of seeing all of the NLRI originated by router 2 on autonomous system 65432 as being originated from AS3 like we did above, we're actually going to see the autonomous system of 65432 be replaced by the AS for router 3. And I apologize, the mouse is kind of moving around there. So let's go ahead and jump on the command line. I've already got the BGP configured here all the way through, and let's take a look at what we've got. So here's router 4, and if I go from user exec to privilege exec, and I say show IP BGP, you can see that I see the loopback addresses for all of the routers, and specifically router 2. You can see here the autonomous system path. It originated in 65432, and then it came through autonomous system number 3, and that is where router 4 learned about it, was from autonomous system number 3. So we already knew how to do the remove private AS. So let's go on to router 3, and let's go from user exec to privilege exec, and let's go into global config, and we're going to say router BGP 3, and if I say do show run section router BGP, you can see that it's not anything exotic here, right? So let's go ahead and say neighbor 10.3.4.4, and we're going to say, whoops, not remote AS, we're going to say remove private AS. So I'm going to do a do clear IP BGP star in, and then I'll do an out. And again, I like to do both of those just to make sure, because it's not resetting anything. It's not resetting the peering, so we're good. And so now I've done the remove private AS. So let's come over to router 4, and let's see what that looks like. And you can see, we saw this in the previous video, where now it looks as if the NLRI, specifically for router 2, which earlier said and showed the private autonomous system number, we have stripped that out. Remember, the reason we're stripping it out is because private autonomous system numbers, we can't guarantee their uniqueness on the public internet. And so just like the RFC 1918 addresses, where we NAT those addresses and we make them look like public addresses. That's kind of what we're getting ready to do here. So the remove private AS literally strips it out. When we say remove private AS all, replace AS, it's like we're sort of like NAT, right? Because we're going to replace the private autonomous system number with a public autonomous system number, just like we would replace an RFC 1918 address like 10.1.2.3 with something publicly routable. So here's what we're going to do. Whoops, sorry. Let's go ahead and make that happen. So on router 3, all we'd have to do is pull that command back up and then say all. If I do a question mark here, you see I could hit enter, but we're going to replace the AS. So I'm going to say remove private AS all and then replace AS. Let's rerun the clear in and out. And now let's come over to router 4 and see what we've got over here now. And we should have 2 instances, and we do. Fantastic. We have 2 instances of the public autonomous system number 3. And so I like that we've got all of this up here on one screen. It makes it nice and easy to see what actually happened. So when we said all replace AS, the private autonomous system number that was originally in the BGP update was replaced by the public autonomous system number, where we set the remove private AS all replace AS. Now, in the diagram that I had earlier, you noticed that we have another autonomous system here behind 65432. And so what we see is we've got a public autonomous system number, we've got a private autonomous system number, and then a public. And so the question is, what's going to happen if we do the remove private AS all replace AS here on our peering going to router 4 when I have a public autonomous system number and a private autonomous system number? What's going to happen? And so let's take a look at that use case as well. So I'm going to go ahead and pull this back. We'll come to the command line here. Let's go to router 3. And first thing we're going to do is I'm going to pull this whole thing back here. We're going to say Control A and then no, and then I'll go ahead and do clear in, clear out. And let's come over to router 2. And again, this is AS65432, so we'll go from user exec to privilege exec into global config, section router BGP, router BGP. And we'll see what we've got here. And remember, I'm doing this. This is on real physical Cisco 1831s running 15.3 code. So we've got a pretty basic BGP configuration. Now I want to create a BGP peering with, router BGP 65432. And we're going to set it up with neighbor 10.1.2.1, and that's going to be router 1, and the remote AS is 1. And so now let's come over to router 1, and we're going to do the same thing here on router 1, autonomous system 1, from user exec to privilege exec into global config. And we'll say router BGP 1, and do show run section. I don't think there's anything in here right now. Router BGP, I think it's totally empty, and it is. So we're going to go ahead and say neighbor 10.1.2.2, and the remote AS is going to be 65432. And let's go ahead and originate our loopback address, which is a /32, into BGP. So we've got some NLRI out there. So let's say do show IPBGP, and that's what we're originating. What about an IPBGP summary? Do we have a peering set up yet? No, it's idle. And let's do a ping real quick here. Do ping 10.1.2.2. All right, so we've got reachability, and hopefully that kind of gave it a little jump start. And we should see this, we should see this peering pop up here in just a second. Let me make sure I've got the correct statement, and I do not. You can see I messed this up over here. So let's pull this back. And that was the problem. It should have kicked in earlier. And that was my key, NEIGHBOR. And 10.1.2.1, remote AS 1. And so we should see that BGP peering come up here pretty quickly. We'll give it a second, and there it is, right? So if I say do show IP BGP, you can see that we are getting the NLRI from Autonomous System 1. Now, what does router 4 see? Remember, we removed the statement to remove the private autonomous system numbers. So what we should see is we have an autonomous system path of 1, 65432, and then 3. So what's going to happen on router 3 when I put the remove private AS all replace AS? What's going to happen with this? And what would happen if I was to simply say remove private AS without the all replace AS? So let's take a look at both of those. So I'm going to pull router 3 up here, and we're already kind of teed up. So I'm going to say neighbor 10.3.4.4, and we're going to say remove private AS. And so we'll start with that one. So let's do a clear out and then a clear in. And let's come over to router 4 and see what router 4 sees. So remember, this is what router 4 just saw. So when I say show IP BGP and we're only removing the private AS, is it going to show that it originated from 1 and then went to 3 and then the private AS is gone? Interesting, right? So take a look at what happened here. It removed the private AS for the 2222, which is coming directly from that private autonomous system, 65432. So it removed that. However, when there's a public autonomous system number and you've got a private number that's mixing in with the public autonomous system number, in other words, the NLRI originated in a public AS, transited a private AS to get to the autonomous system where we did the remove, you can see that it does not do the removal. And so it's here that I'm going to pull up. Vinit Jain has a great book, Cisco Press book on troubleshooting BGP. And you can see here it says, if the AS path for the route has a private autonomous system number between public autonomous system numbers, it's assumed that that is a design choice, and the private ASN, or autonomous system number, is not removed. However, if the AS path for the route has only private ASNs, which it did in this instance here, it would have had just the private ASN number, not the private in between two publics, then it does get removed. And so you can see he actually talks about the different scenarios that can happen. And I'm not going to get into the confederation sequence one. That's almost ridiculous in terms of setting that up. So we've got the remove only private ASNs advertised on routes advertised to eBGP peers. If the AS path for the route only has that private ASN, it gets removed, which is what we saw. But as soon as the AS path has a private ASN between public ASNs, it is not removed because this is considered to be a design choice. And so that gives you some options in terms of how you want to have things removed. And so this worked out rather nicely, being able to sort of walk down the different setups. So now let's see what happens when we say remove private AS, all replace AS. And the question is here, is it going to say 3.3? And what is it going to say there? Is it going to say 1.3.3 or is it going to say 1.65432? So let's check that out and see what's going to happen. So let's pull that command back and I'll say all replace AS. And so we'll do our clear out and then our clear in. And then we'll come back over here to router 4. So let's take a look and see what's going to happen. And take a look at that. So this is interesting, right? Because it won't remove it, but if we say replace the AS, then it will replace it. So it's true that if the private autonomous system number is between two publics, you can't remove it, but you can replace it. And you can see the difference there. And of course, right, we anticipated that was going to happen, because instead of removing it and making it look as if the NLRI had originated from Autonomous System 3, we're now replacing the autonomous system. However, this one here, right, was a little tricky. Was it going to remove it? Was it going to replace it? What was it going to do? And so here's the original when we had simply remove private AS. And here is the autonomous system path when we said remove private AS all, replace AS. And what ended up happening was our 65432 was replaced with the public autonomous system number in order to maintain the AS path length. So let's take this one step further. What if I'm doing AS path prepending with that 65432? What would that look like if I was to do this replace? And so let's go ahead, let's do some AS path prepending real quick here. And this will actually be pretty easy to do. So we're going to come over to router 2, right? Because that's where I'm originating the NLRI that I'm passing, or the 2222 that I'm passing on to router 3. And we're going to go ahead and AS path prepend here. So let's exit out. I'm going to say IP prefix list NLRI, and we'll only do it for the 2222. And we're going to say, we'll get the sequence number in here. I like to do 5, and then we'll say permit 2222/32, and then we'll do up a quick route map here. So we'll say route map NLRI. I'm just going to hit enter, and remember, it's implied that if you type route map something, the name of the route map, right, and hit enter, that it's an implicit permit 10. So now let's go ahead and say match IP address prefix list NLRI, and then we're going to say set AS path prepend, and I'm going to prepend 65432 space 65432 space 65432 65432. All right, because we'll keep it at 5, right? So it shows up with 5. All right, so now we need to go into router BGP 65432. And our neighbor statement to router 3 is going to be 10.2.3.3. And I'm going to apply this route map now, NLRI, in the outbound direction. So let's go ahead and say do clear IP BGP star in, and of course the out. Right, again, I could get away with just doing the out. I just do in and out both times, right? All right, so now let's come over to router 3, and let's do a do show IP BGP, and let's see what we see here. Did the prepend work for the 2222? Do I have 5 occurrences of that autonomous system number? I do. However, let's see what the effect is now with the AS path prepending over here on router 4. Are we going to see 33333, and then the same thing here? Because remember, we're removing the private AS, but then we're replacing it, right? We're not just getting rid of it, we're replacing it. So let's see what we see. And take a look, right? And actually, we weren't going to see anything. The 222 was there. You can see the 111, because I cut it out with the route map. I would have to come back over here. Whoops, sorry. If I wanted to continue to see the 111, I would have to say, where are we at here? Let me come out. Let me say route map. Sorry. Route map NLRI permit 20. Right? Because then everything else is going to come through, and then that would solve it, and I could probably rerun the do clear IP BGP in and out one more time. And so what happened was, to make sure I'm clear here, my route map that I had set up, I had a single permit statement, and I basically prepended to the 2222, and then I forgot to say route map NLRI permit 20 so that all the other NLRI would still be able to make it through, right, to be advertised, because there's an implicit deny everything at the end of the route map. So now that that's been taken care of, if I come over to router 4 and let's rerun that command one more time, we're going to see the 1111 now. And so now it's back. So, but we're not prepending for the 1111. So let's take a look here. So take a look at what happened. Pretty cool, right? So we did the prepend, and it's still honoring the prepend. It's just simply replacing it with 1, 2, 3, 4, 5 instances of 3, right? Which is replacing the 6543 2. And so let's back ourselves out of this little by little. And if we came here and if I was to say, and we'll pull this off here, and then I'm going to enter it in again. We're going to say neighbor 10.3.4.4. And now we're just going to say, oops, sorry, I keep saying remote. Remove private AS. So I'm not going to have the all replace AS. And let's see what happens here. So we'll clear the inbound, and then let's clear the outbound. And now let's come over to router 4. Oops, come over to router 4 here, and let's see what router 4 is going to show. And it's exactly what we would think, right? And we've got the private AS in the middle. Remember, we're not replacing it, so it can't remove it because it's in between. This would be a design decision that you had made, and oops, sorry. And that is why it's not being removed here. However, it is being removed here because it wouldn't be considered in between two public ASs. It would have been, if I scroll back up, it would have been this right here, where it's not in between, right? It's the originating autonomous system. It's not in between. The one is not there like it is up here. All right, so that looks great. And we removed it, and you'll notice we don't get 5 instances of anything because we're not replacing it, so it's getting removed. All right, well, I think that's a number of iterations there, so hopefully the difference between the two makes sense in terms of remove private AS, what that's going to do and how that's going to behave. We saw that in the first video, and we saw it here too. And then remove private AS all, replace AS. And the effect that that has, and specifically, and I'll call it a corner case here, where perhaps you've got a private autonomous system in between two publics, and you might think that, hey, I'm just going to do the remove private AS, replace AS, or I'm sorry, the remove private AS, and that's going to work. And you can't remove it because it's in the middle of two public ASs. And so you might be thinking to yourself, well, wait a second. Well, couldn't I just do like AS override? Well, the thing with AS override is that it's only going to work when you're using the VPN v4 address family, right? So that's when we're talking about MPLS. So here we're just talking about BGP flying around without MPLS and without VPN v4 address families configured. So that's why AS override is not going to work in this scenario. All right, well, that concludes this Hut8 Techtorial. Again, I hope I've cleared up any confusion that you might have had or sort of lit that spark of curiosity with the remove private AS and the remove private AS all, replace AS. All right, thanks so much for watching. Have a great weekend.